So in this class we will discuss H parameters, hybrid parameters. What do you mean by H parameters? Hybrid parameters, they are also called as H parameters or known as hybrid parameters, as they use Z parameters and Y parameters, voltage ratio and current ratio, to represent the relationship between voltage and current in a two-port network. It has properties of both Z and Y parameters, impedance and admittance parameters. So it uses Z parameters as well as Y parameters to form the equations. Also, in the Z parameters, we will have only voltage ratios, and in Y parameters, we will have only current ratios. But we will find combinations of both ratios here, voltage as well as the current. That's why it is called as a hybrid parameters. The H parameters are useful in describing the input-output characteristics of circuits where it is hard to measure Z and Y parameters. That's why the H parameters are used here. H parameters encapsulate all the important linear characteristics of circuits, so they are very useful for the simulation purposes. The relationship between voltage and the current in H parameters can be represented as. Before discussing the H parameter equations, let us revise. What is Z parameters? V1 is expressed in terms of current using Z parameters. Alright. So V2, the voltage V2 is expressed in terms of the current plus. Alright. These are called as a Z parameters. Next, Y parameters. Currents are expressed in terms of voltages. Currents are expressed in terms of voltages. I2, they are called as Y parameters. Now, Z parameters are calculated by open circuiting the input and output ports. Y parameters are calculated by short circuiting the input and output ports. Why the H parameters are invented? The reason is it is difficult to make open circuit the output port because it will be having infinite impedance. Alright, the second issue, in case of Y parameters, if output port is short circuited, there will be infinite flow of the current. I repeat here, the problems of Z parameters and problems of Y parameters. In case of Z parameters, they are calculated by open circuiting the output port. If the output circuit is open circuited, then it will be having infinite impedance. The second point, in case of Y parameters, they are calculated by short circuiting the input and output ports. If we short circuit the output port, then there will be infinite flow of current. These two cases are not recommended for the circuit. That's why there is an invention of H parameters. Alright. So that, keeping that point in our mind, we will define V1 and I2. So these are the input voltage is expressed in terms of input current and output voltage. The output current is expressed in terms of input current and the output voltage. You should keep this point in your mind. Along with these two, these four equations, the third set of equations, V1 and I2 are expressed in terms of I1 and V2. They are called as H parameters. H11, H12, H21 and H22. Where V1 is the input voltage, V2 is the output voltage, I1 is the input current, I2 is the output current. Alright. Then how to determine the H parameters? These two are the equations. Then H11 and H21 can be calculated if these two terms are 0. These two terms are 0 if V2 is 0. If V2 is 0, the meaning of this is output port is short circuited. The parameters H11 and H21 may be determined by short circuiting the output terminals of the given circuit. So that, see here, it is what an equivalent circuit. It is a two-port network. It has one port, second port, it is called as input port, it is called as the output port. So these are the equations. To calculate H11 and H21, these two terms should be 0. They can be made 0 by setting V2 as 0. You can see here output port is 0. Here output port is made 0. If V2 is 0, then definitely we will get H11. What is H11? V1 divided by I1. What is H21? I2 divided by I1. That's all. Next, how to calculate H12 and H22. These two can be calculated if these two terms are 0. Then these two terms are 0 if I1 is 0. If I1 is 0, the meaning of that, I1 is 0, the meaning of this is input port is open circuited. I repeat, to calculate H12 and H22, these two terms should be 0. They can be made 0 if I1 is 0. I1 is 0, another name for this condition is input port is open circuited. That's all here. On the other hand, H12 and H22 may be determined by the open circuiting the input terminals of the given circuit. So here the input port, here it is the output port. In this case, the input current is made 0. Input current is made 0. The meaning of this is input port is open circuited. That's why they are called as a hybrid parameters. It has both the short circuited and open circuited properties. Because of those two, they are called as a hybrid parameters. It has the characteristics of H, it has the characteristics of impedance and admittance parameters. That's why they are called as H parameters. Is that okay? Can you reply? Repeat once. Do not worry. It will be repeated. Alright. Let us revise the same thing. I repeat here. H parameters, they are called as hybrid parameters. These two are the equations. These two are the standard equations. V1 and I2 are expressed in terms of I1 and V2. Keep that point in your mind. H parameters, you must remember these two equations. Alright, to calculate H11, this term should be 0. This term will be 0 when V2 is 0. Fine. V2 is 0. The meaning of this is V2 is output port voltage. If it is 0 means, is that short circuited? I repeat here. V1 equals to H11 I1 plus H12 I2 V2. We are in need of calculation of H11. To calculate this term should be 0. This term will be 0 when V2 is 0. V2 is 0. The one more name for this is output port is short circuited. Alright. If output port is short circuited, we can calculate H11 and H21. That is done here. When output port is short circuited, we can calculate H11 and H21. Fine. Let us calculate H12 and H22. H11 and H22 can be calculated if these two terms are 0. This term and in this equation, this term. So, this term can be 0 if I1 is 0. Alright? I1 is 0. One more name for this is I1 is the input current. If it is 0 means there is no flow of the current. The meaning of this is input port is open circuited. See here, in this case the input current is 0. The meaning of this is input port is open circuited. At that time we can calculate H1, H12 and H22. Is that okay? Yeah, good. Then we'll go ahead. Okay, see here. Then what is H11? H11 equals to V1 divided by I1 provided V2 equals to 0. Is that right? V1 equals to, H11 equals to V1 divided by I1. What is that condition? V2 is 0. So it is called as input resistance. The condition is output is shorted. Is that fine? What is H12? What is H12? H12 equals to, it is 0, assume that it is 0, so that V1 divided by V2. What is condition? I1 should be 0. And it is called as, H12 is called as reverse voltage gain. The condition is I1 is 0 here, so that input is open. I1 is called as the input port current and it is 0. One more name for this is open circuited. Let us calculate H21. H21 equals to I2 by I1. The condition is, it happens when V2 is 0. It happens when V2 is 0. It is called as forward current gain parameter. Forward current gain parameter. And it happens when output is shorted. You can see here V2 is 0. One more name for this is short circuited current. Short circuited port. Here it is V2, output port. That's why when V2 is 0, we can calculate H21. We are in need of H22. H22 equals to I2 divided by V2 provided, what is condition? I2 divided by V2 provided I1 is 0. I1 is 0. I1 is input current and it is 0 means input is open circuited. Input is open circuit and it is called as output conductance. Output conductance. You can see here these two are the unitless quantities. Here you don't find any unit here because same quantities are divided here. These H12 and H21, they are unitless quantities and unit of H11 is ohm, unit of H22 is mho. It is impedance, it is admittance. Fine. Impedance is voltage divided by current here. Here it is current divided by voltage here. So that Siemens or mho, it is impedance ohm. Is that okay? Fine. We'll go ahead. This is what equivalent circuit here. I will write here V1 equals to H11 I1 plus H12 V2, I2 equals to H21 I1 plus H22 V2. Okay. Is it nothing but characteristics of Z parameters? It is the equivalent circuit of H parameters. And is it nothing but characteristics of Y parameters? Because of these two, they are called as hybrid parameters. A network whose input port can be represented using Z parameters. A network whose output port can be represented using Y parameters, that is called as here the H parameters. Input voltage and output current. Input voltage and output current are expressed in terms of input current and the output voltage. They are called as H parameters. You should keep this equivalent circuit in your mind. Alright. Next, important. Express Y parameters in terms of H parameters. So, it is an important derivation. First, write down Y parameters. What are Y parameters? I1 and I2 are expressed in terms of voltages here. I1 equals to Y11 V1, Y12 V2, Y21 V1, Y22 V2. Call this as equation number 1. Call this as equation number 2. Next, H parameters are here. Write the expressions. H parameters where V1 is expressed as H11 I1, H11 V2, I2 is expressed as H21 I1, H22 V2. Call this as equation number 3. Call this as equation number 4. Means we are finding the relationship between Y parameters and H parameters here. So here Y parameters should be expressed in terms of H parameters. This is what the requirement here. Y parameters, these equation number 1 and 2 should be expressed in terms of, it should be expressed in terms of H parameters. Alright, for that what I will do, I will take equation number 3. Consider equation number 3. From that I will write H11 I1 equals to V1 minus H12 into V2. I1 equals to 1 by H11 into V1 minus H12 divided by H11 into V2. Call this as equation number 5. Now compare equation number 1 and 5. Compare equation number 1 and 5. Left hand side is same, I1 and V1, sorry, I1 and I1. RHS side, V1 is here, V2 is here. So that, what is Y11? Y11 equals to 1 divided by H11. Now, after comparing equation number 1 and 5, I can write Y12 equals to minus H12 divided by H11. Simple thing here. Means, do you say that Y parameters are expressed in terms of H parameters? Is that right? Two parameters. If I know the H parameters, then easily I can get the Y parameters. The meaning of this derivation. Alright. Next. We are in need of two more parameters. I will substitute. Put equation number 5 in equation number 4. What I will write here? I2 equals to H21. What is I2? What is I1? Is this case? Complete this one. 1 divided by H11 into V1 minus H12 into H11 V2. Now plus H22 into V2. Then simplify this. Simplify this. H21 into H11 into V1 minus H21 into H12 into H11 V2 plus H22 into V2. Do simplify. I2 equals to H21 into H11 V1 plus, you can see here V2 is common, take it outside, then LCM of this is H11, this H11 is multiplied to this term, so that H11 into H22 minus of this H21 H1. Okay, can I write this as I1 equals to H21 divided by H11 into V1 plus, is this nothing but delta of H? Call this as equation number 6. What is this delta of H? You can see here, is this a determinant? If you take a matrix H11, H12, H21 and H22, what is determinant of it? Is this nothing but H11 into H22 minus H12 into H2. So this numerator is replaced by a delta H. Then compare equation number 2 with 6. Equation number 2 with 6. What will get? Y21 equals to H21 divided by H11. Next, Y22 equals to delta of H divided by H11. That's fine. Is that okay? You can see here. We have discussed this Y parameters in terms of Z parameters. Next, Y parameters in terms of H parameters. If I know H parameters, then easily I can write a Y parameters. That is the concept here. What is Y11? Y11 is nothing but 1 by H11. Is that right? What is Y12? Minus H12 divided by H11. What is Y21? It is H21 divided by H11. What is Y22? It is delta H divided by H11. That is discussed. So express the Y parameters in terms of H parameter. Important derivation. So for this, the key point is these four equations. Then adjusting equation number 4 and 3 according to equation number 1 and 2. So that comparing and getting the result. Is that okay? Is that okay? Are you able to express this? Good. Very good. Then are you able to express Z parameters in terms of H parameters? The second next derivation. It is also one of the equations. Here you have to consider 4 equations, 1, 2, 3 and 4 equations. In first and second you should write Z parameters. In third and fourth write H parameters. Adjust equation 3 and 4 such that they should be compared with equation number 1 and 2. Then write down. Are you able to do it? Try. Do not worry. Try yourself first. Later in next class I will derive this expression. So take a screenshot of it. Take a screenshot of it. So it should be the result. So Z parameters, they are expressed in terms of H parameters. It should be the result. Take a screenshot of it. Try to get these values. Alright. So today we do wind up the class by taking the attendance.